to recording. We have a delay on some of our friends. There we go. So we're missing Bree and Ashlyn. And who else? Natasha. I'm mad I didn't catch it. That we were running out of time.
Yeah, I didn't see it either. It was just like exited out.
I knew we were getting close because my Google Calendar told me so, but other than that.
Oh, yeah. Mine did too, but I wasn't paying attention because I was getting too excited about this whole like being close to pi divided by 4 thing. So let's go back to that.
So exciting.
It is.
It is though.
No, we are. It was interesting. I saw it and I was like, what?
A minimal mathematical error. Like that's like, kind of cool.
Yeah, and the more you do of these, go back to that. So the more you do of those things, you're going to get closer and closer and closer to where this is just going to be roughly 0.7854. And this is going to get really, really close to 1. Meaning it would be perfect almost. Which is neat, right? So you can start to see this trend. So this, since the degree on this function that models this is a degree 2, that's related to our units being squared units. So these would be squared centimeters for the area, right? A 2 and a 2. Does that make sense? Since it's a 2-dimensional thing that you have square units and it's modeled by a 2nd degree polynomial. All that stuff is related. Yes, I know we don't have to teach this. We're obviously not going to teach this level of regression in elementary school, but it should kind of hone in on you remembering that units are squared per area. So yeah, that's the big idea. But these are activities that you could just do with students as like making these tables and plot points. And you can be like, does it look straight? It might not be straight, that kind of thing. So we might have to think of something else. So just like as an extension to when y'all are talking about area, that's probably as far as I would go with that part. Does that make sense? There we go. So yeah, that was the big activity. I wanted to do one more, but I don't think everybody has access to graph paper. Does everybody have graph paper at home?
No.
No. Yeah, so we'll kind of next that activity. Do I have everybody back? I lost Ashlyn.
Yeah.
Wait, I don't think Kiara's here.
Yeah,
Oh, she's right
Oh
here.
no, there she is. My bad.
Jeez, Matt, trying to get people in trouble for them not being here.
I didn't see her.
Well, I can see.
Yeah. Well, that was the big thing that I was gonna have for y'all. That was our math activity for today. So.
I had a question from the reading.
Sure.
So it was talking about how we talk about like the signs like plus and minus. So it says that the minus sign should be read as minus or subtract, but not as takeaway. It was like a really big thing in the book. They were like, don't say takeaway. I was like, okay. Like it makes sense when they get up into the upper grades and they're doing like more than one minus sign, and obviously it's not takeaway. Is that why we lay the foundation? I've always found it like an easy way to explain the
Is this the 12 rules paper? Is this the 12 rules paper or
This is the textbook.
oh, textbook? Oh, sorry. Okay. So when we start talking about things as takeaways, so like when we say take away a negative number of things, it doesn't seem to take this same sense, right? Is that,
Yeah. But like reading like 5 minus 3 as 5 and then you take away 3, how many do you have left? Like
2.
that's
Right.
not kosher.
Well, like as how I would interpret that, it would just be like 5 take away 3 is you would just take away that 3 and then you just have 5. Because I've seen kids do that before.
And that too.
Okay.
So like, even though that these are called takeaway problems, yeah, it gets real. So that's one of those things. Like same thing when people say plug in instead of substitute. You're not literally plugging something in, so there's going to be a lot of like language barrier kind of things. We also say flip it when we mean multiply by the like talk about reciprocals. Like students will like visually flip numbers in their head and write them upside down.
Oh.
So yeah, so that's one of those language things, is that's why they say don't say takeaway. Also, when you write, we talked about this a little bit in 103. So when we're talking about things like 3, we would say -3, or we would say -3. But then when we have this, you're adding the opposite of 3. So they would get really hung up on that language about adding a -3. We would say that, right? And so they want you to be very clear about what that means.
Okay. That makes sense. I just wanted to talk it out. So that,
Yeah. It's one of those things that the majority of people catch on to those colloquialisms, but some don't. Just like when we talk about what is the diameter of a circle, the term diameter technically means the length of the chord that goes through the center, not the diameter itself is 3. We would say the length of the diameter is 3. Does that make sense? And then over time, as a colloquialism, we just say the diameter is 3. We actually mean the length of the diameter is 3.
yep.
So that's where this whole thing about like when students are defining these measurements, when they say radius is 2, they mean the length of the radius is 2. The radius is actually a line segment that can't be an actual number. It's a segment. So it's one of those colloquialisms. Over time, we just know. But especially when there's English as a second language, those things get really convoluted in their mind.
Yep.
And then also like, and this was something that came up in my interventioning when I was teaching right angles. She was translating it in her head as it being correct, not like 90 degrees, because it was right. So that was one of those things that she was not understanding when I was saying a right angle. She's like, how can an angle be correct? Like it was answering a question correctly. So that's one of those things that we have to be careful about, especially when there's other language speaking students in the classroom. Does that make sense?
Yep.
Because did I assign that paper to y'all, or did I send that paper to my 104 class? It's all blurring together now. Where's my Moodle?
So I have a question about that right angle example. So would you still say right angle and just clarify that in this case, right means 90 degrees?
Yes, that's what I had to get to.
Okay.
She was like, and for a while there, I wasn't realizing that's what she was doing, because a lot of the stuff she was missing, it's not that she didn't understand it. She just didn't have the right frame of the context that was what we were talking about. And then like when I had somebody actually translating with me, and then I heard her say it in English and Spanish to me, I'm like, oh, like, because that student was also translating it as correct and not right as 90 degrees. And that's
Okay.
like, I was only able to figure that out after multiple conversations. So I was just talking like she knew what I was talking about, and she was like, you know, just trying to be compliant essentially. She was just agreeing with me. She's like, okay. And then like when she was actually doing the problem, she had no idea what was going on. So,
Okay, I just wasn't sure if that like right angle was, if that was like what it was actually called, if there was like a more formal word for it that we should
call
be
it
using.
a 90-degree angle is a right angle.
Okay.
So yeah.
So what do you do
I mean,
when a
and
student?
it took me like 3 days of working with her before I realized that she wasn't translating that correctly. So it was weird.
So what do you do for a student that asks like the difference between a right and a left angle?
So that is a very interesting question, which I don't doubt actually happens in real life.
Oh yeah.
So when we say the word right, we're actually talking about the type and not its like location in relation to something on the left and the right. So, but in the pictures, like for example, if we see something that looks like this, we're actually talking about something on the right side of that ray and on the left side of that ray. So they could easily see that this is the right angle and this is the left angle. I could see them saying that. But when we say a right angle, we want to see it with that box. So this right as a name, not right as a location. So, and like what I would do is literally start making flashcards with your kids that actually show these like drawings, and then like on the back say like right angle, and then like have things that look like this. And so this is, so that would be an acute angle, and then obtuse angle. And so like I would draw multiple of these things and then actually draw one that looks like this, and then draw one that looks like this, so they can start to see that these all mean right angles, not like it's on the right of something. That is a good question. Other questions? Are we good? So I'm going to keep working on things, and we will tentatively meet next Tuesday at this time. I'm working on trying to get things for us ready to go so that it has more of a flow to it again. And I'm going to work on updating the assignment sheets for y'all. Also rewriting the syllabus for y'all, so that way things are a little bit more clear in this muddiness. So, but yeah, definitely you're welcome to email me. Also, I can individually Skype with y'all if y'all have other questions. I'd be happy to set that up with y'all. I wish I was more definitive in knowing what was going on, but obviously things are changing day to day and hour by hour in some cases. So, but you know.
So good. Thanks, Joni.
Yeah, I'm gonna do what I can. So please just let me know if y'all need anything. Okay?
Thank you.
Thank you.
Alrighty.
Thank you, Joni.
Okay,
Alright.
thank you.
Yeah. All right. Well, I will talk to y'all later, and of course, just email me if y'all have any more questions.
All right.
Cool.
Okay.
Alrighty. Well, bye guys.
Bye.
Bye.
Bye.